Good morning, good evening. Welcome everyone to the next Gen 4 International Forum webinar presentation. Today's presentation on China's multipurpose SMR ACP100 design and project progress will be presented by Dr. Danron Song. Doing the introduction today is Dr. Patricia Pavier. Patricia is the group leader of the Radiological Materials Group at Pacific Northwest National Laboratory. She's the National Technical Director of the Molten Salt Reactor Program for the Department of Energy. And she's also the chair of the Gen 4 International Forum Education and Training Working Group. Patricia.
Good morning, good evening, everyone. Thank you, Bertha. It's a pleasure to have Dr. Song Dan-rong with us today. He is the chief designer at the Nuclear Power Institute of China. He earned his Bachelor of Science degree in Mechanical Engineering in 1991, his Master's degree of Business Administration in 2003, and in 2009 he received his doctoral degree in Nuclear Science and Engineering from the Nuclear Power Institute of China. Currently, he works as the chief designer of the SMR demonstration project ACP100 in China. Dr. Song specializes in small and medium reactor overall design, isotopic production reactor overall design, seawater desalination, and low temperature nuclear heating plant feasibility studies. So without any further ado, you have the stage, Dr. Song. I wanted again to thank you very much for volunteering to give this webinar. Thank you.
Thanks, Ms. Patricia and Ms. Berta. Good morning and good evening for every audience. I'm very glad to have this opportunity to introduce you the small and medium-sized reactor developed in China. My presentation is as following. There are 7 contents in my presentation. The background introduction of ACP100, design parameters of ACP100, and the technical aspects, safety and licensing strategy, testing and verification, demonstration project of ACP100. Next slide, please. So let's go to the definition of SMR. SMR is one kind of new generation reactor designed to generate electric power up to 300. The components and the system can be shock fabricated and then transported to the site for installation. Next. By adopting modular design and construction concepts, the SMR is a passive safety technology, can reach high power by several modular combinations, and can be used in different places and in different conditions. Next, please. So we know there are a lot of large nuclear power plants, but they have challenges nowadays. First is the industry capacity and transportation for large components, and marginal effects on economic by increasing power. Difficulty with application of passive technology due to a huge reactor power. And the large nuclear plant have huge overnight investments. And the large nuclear plant not flexible for alternative use. Next, please. Non-electrical application for nuclear energy and the needs in developing countries from nuclear electricity. By calculation, in 10 to 20 years, 70% of the energy consumption in developing countries will be non-electrical application, such as heating, transportation, seawater desalination, etc. Next, please. Not like the large nuclear power plant, small and medium-sized reactor, small modular reactor achieve its economic by simplifying modular design and increasing the number of modules. And the SMR with lower power and lower residual heating, they are suitable for passive safety facilities application. Is the advantage of safety for SMR. Next, please. The SMR is suitable for small electrical grid district heating, process heating, seawater desalination, according to varying conditions. Different countries have different goals. In China, we developed the SMR for district heating, steam. In Middle East countries, they develop SMR for seawater desalination. Next, please. Next, please. Okay. There are a lot of SMRs are developed by different countries. In IAEA, International Atomic Energy Agency, they published a booklet for SMR. In 2020, there are 72 reactors developed by 18 member countries. 1/3 of them are PWR type, and most of them are integrated reactors. Next, please. In CNNC, we call our SMR named ACP100 is an innovative PWR based on existing PWR technology, adapting passive safety system and the integrated reactor design technology. CNNC starts R&D on ACP100 in 2010. The modular design technique is used to control the product quality and shorten the site construction period. Next, please. This is the roadmap of ACP100. We start the R&D on ACP100 in June 2010 and selected the site of a first of kind in 2016. And we finished our IAEA generic reactor safety review in April 2016. And the preliminary feasibility study approved in May 2017. Feasibility study completed in 2017. And the basic design finished in 2018. The environment impact report approved by our National Nuclear Safety Agency in 2019. And our preliminary safety analysis report approved by National Nuclear Safety Agency in 2020, in June 2020. So there are about 10 years for ACP100 R&D from the beginning to approved by our National Nuclear Safety Agency. Next, please. Next, please. This is the design parameters of ACP100. The main design parameters. The thermal power is 385. Electrical power is 125. The design life is 60 years. Refueling period about 2 years. The current inlet temperature and outlet temperature is from 282 to 323. The current average temperature is 303. The best estimate flow rate is 10,000 cubic meter per hour. Operation pressure is 15 megapascal. The fuel assembly type is CF3 shortened assembly. Fuel active selection height is 2,150. Fuel assembly number is 57. Next, please. The fuel enrichment is lower than 5%. The mechanical drive mechanism type is magnetism lifting. Control rod number 25. Reactivity control method including control rod, solid burnable point, and burn. Steam generator type is one-through steam generator. There are 16 one-through steam generator inside the reactor vessel. The main steam temperature is more than 290. The main steam pressure is 4.5 megapascal. Main steam output is 560 tons per hour. The main feed water temperature is 105. The main pump type is canned pump, and there are 4 canned pumps connected with the reactor vessel. Next, please. Reactor power control operation program is primary constant average temperature. The thermal power operation model is base load operation. Model A means Model A. Plant design life 60 years. Seismic level ground seismic peak acceleration is 0.3. Predicted core damage frequency CDF lower than 10-7. Predicted large release frequency LRF is lower than 10-8. Next page. Next, please. One reactor with one turbine layout. This is the reactor layout. This is a reactor building, and this is a turbine building. Okay, next. Next, please. Okay. This is technical aspects of integrated reactor module. The reactor coolant system has been integrated in the reactor module. The reactor module consists of reactor vessel, one-through steam generator, canned pumps, reactor internals, and an integrated reactor head package from the lab. Okay. The reactor coolant system is composed by 4 main pumps, 16 one-through steam generator inside the reactor vessel, 1 pressurizer. The system operation pressure is 15 megapascal. Core inlet temperature is core outlet temperature is 325. Next, please. This is a reactor core layout and the advanced core dictation system inside the reactor core. There are 17 plus 17 square fuel assembly with gadolinium oxygen solid burnable poison. Refueling period is 24 months. Next, please. The control roll drive mechanism, the step is 15 millimeter per minute. Max travel speed is 72 millimeter. Electrical mechanical delay time is less than 150. Temperature is 200. Pressure house design life 60 years. The number of non-service is 6 million steps. Next, please. This is the fuel assembly 17 plus 17 square arrangement, like large nuclear power plant fuel assembly, but the shorted. Fuel rod is 264, guide tube 24, instrumentation tube 1. Total height is 2,500. Active loss is 2,150. Next, please. The main steam system is composed by main steam system, bypass system, moisture separator, reheat system. And the system description, operation pressure is 4.5 megapascal, temperature is 285. Next, please. Next, please. The I&C system, the function of I&C system divided into 4 layers. The interface layer, auto control and covering layer, operation and management information layer, the plant technical management layer. Next, please. The safety system of ACP100 is fully passive. ACP100 adopts a fully passive safety system illustrated in this figure. Passive core cooling system, passive residue heat removal system, the passive containment heat removal system, passive inhibination system, automatic depredation system, passive hydrogen control system. Next, please. The passive residue heat removal system, we know the heat exchanger is mounted in the inner water storage tank. Heat exchanger is usually filled with the current. Natural circulation from the reactor core to the inner water storage tank, and transfer the heat from the core to the inner water storage tank. Next, please. The passive core cooling system provides reactor coolant system emergency makeup. Safety injection provides adequate core cooling for small break lockup by the CMT, by accumulator, and last by the inner water storage tank. After the CMT, accumulator, and the inner water storage tank, the water have injected containment. Inside the containment is flooded sufficiently to provide recirculation flow. Next, please. The passive cavity flooding system provides a means of external reactor vessel cooling under assumed severe accident condition, prevents the core from melting. Next, please. The passive containment cooling system provides long-term heat removal from the containment in the case of DBA and BDBA, including those associated with blackout and spray system failure. steam condense on the containment heat exchanger. Condensate collected in the inner water storage tank or sump via the gutter arrangement. Core heat is ultimately transferred through the containment heat exchanger to the surrounding atmosphere by natural circulation, by air natural circulation. The other safety system provide the automatic depressure ADS in the event of small break lockup, passive combustion gas control in containment. Next, please. About the safety and the licensing strategy for ACP100, the code and standards applied by ACP100. First is the level 1 laws issued by the Congress. It's mandatory. Level 2, code and regulations issued by the State Council, mandatory. Setting up administration scope, principles, organizations, and its functions. Level 3 is the department rules issued by government organizations, mandatory. Defining the implemental method based on the regulation, set up nuclear safety objects, and basic requirements issued by our National Nuclear Safety Agency. Level 4 is the guides issued by the government organizations recommending the methods or procedures to satisfy the safety requirements. Level 5 is the technical documents issued by the government organizations. It's a referential. Next, please. Next, please. This is the we can see from this this picture. The first level is the law by our People's Congress. Secondary is a regulation by the State Council. Level 3 is department rule by government departments. And the fourth, the safety guides by government departments. And the fifth level is the technical documents, also by our government departments. Next, please. Safety design conception of ACP100. First is no active emergency core cooling system, no active containment spray and recirculation system, no need for operator intervention after accident for 72 hours, no safety related emergency AC power, nuclear steam supply system, integrated design, minimize both the possibility and the impact of design-based accident. Mitigate DBA without non-safety system. Emergency plan zone is limited inside the site boundary. Next, please. Safety design in defense in deeps. Defense in deeps is critical element of safety principles and has been incorporated into all the safety related activities to guarantee that those activities are protected under overlapped safety measures. 5 layers of DID measures are incorporated into ACP100 design. Next, please. ACP100 has robust multiple physical barriers to prevent radioactive materials release. These barriers are composed of fuel matrix cladding, reactor coolant system barrier, containment, and aircraft protective containment. ACP100 design guaranteed the effectiveness of every barrier and provide protection layers. Next, please. This is the special design aspects of ACP100. The integrated primary system, animation of large brake locker, candid mount pump, reducing the small brake locker, negative feedback coefficient and decrease the linear power density, increase safety margin, high capacity of natural circulation in the primary system provide the inherent safety. Next, please. Next, okay. The core makeup tank and the accumulator provide the core coverage. All injection water with burn, forbidden the core return to critical. Multiple stage of ADS provide the core depressurization. Passive residue heat remove submersion of cavity during accident. Natural circulation between core and cavity. Heat conduct to outside of the containment by natural airflow. Provide the decay heat removed from the reactor core to the ultimate heat sink. Next, please. After done the deterministic and the possibility safety analysis, from the deterministic safety analysis, 7 categories, including 50 kinds of incidents and incidents, are analyzed, and 15% of thermal margin achieved. After done the possibility safety analysis, the core damage frequency is 1.9 plus 10 minus 7, and the left is 10 minus 8 level. Next, please. And after the analysis, the non-residential area and planned restricted room study, the non-residual area less than 300 meters. For large reactor, it's 500 meters. Planned restricted room less than 500 meters. For large reactor is 5,000 meters. Emergency plan room, EPZ, inner room less than 500. For large reactor, 3,000 to 5,000 meters. The external room less than 600. For large reactor, 7 to 10 kilometers. Next, please. The severe accident prevention and mitigation measures by ACP100, including the following: automatic pressure release system, prevention of high pressure core melting; passive hydrogen recombiner, prevention of hydrogen explosion; reactor cavity flooding by gravity water injection; prevention of reactor vessel failure and melting through containment vessel bottom plate; passive containment heat remove, prevention of containment overpressure. Next, please. The safety and the licensing strategy we have done, including the third-party verification. The International Atomic Energy Agency gives the review comments on ACP100 generic reactor safety review GRSR report on April 22, 2016. This is the first SMR completion of GRSR in the world. According to the safety documentation. The ACP100 is an innovative design that belongs to the SMR class of nuclear power plants and deploys passive safety features. It can be expected from new designs that they are capable of dealing with extreme environment conditions and multiple failures to assure that early or large radioactive release are practically eliminated. Next, please. We have done a lot of testing and verification in our institute. There are 7 testing research projects have been done. They are including control roll driveline cold and hot test, control roll driveline anti-earthquake test, internal vibration testing, fuel assembly critical heat flux testing, passive emergency core cooling system integration testing, CMT and passive residual heat removal system, passive containment heat removal testing. Next, please. This is the control roll dry line cold and hot testing, control roll dry line anti-earthquake testing, which performed in our institute. Next, please. The passive emergency core cooling system integration testing. Over 3 years, our institute have constructed the most comprehensive passive engineering safety system. Core cooling system integration testing are performed. Passive residual heat removal system are finished on this facility. Next, please. This is the fuel assembly critical heat flux testing. Next, please. The passive containment heat removal testing. The result of the testing indicates the passive containment heat removal system is sufficient to conduct the heat to the ultimate heat sink by natural air circulation. Next, please. Now let's go to the demonstration project of ACP100. The Changjiang nuclear power site in Hainan province, located in the south of China, the Hainan island, choose in Changjiang nuclear power plant site. We choose for the first of a kind ACP100 demonstration project, FCD in July 2021, last year. Construction period of first of kind in 55 months. Target commercial operation in 2026. Next, please. We can see there are already 260, 150 nuclear power plants, large nuclear plants, already operation on this site. And there are 2 Hualong 1,000 nuclear power plants under construction on this site, and 1 ACP100 under construction on this site. Next, please. The major equipment of ACP100, such as reactor pressure vessel, steam generator, and turbine generator, are already in the manufacturing stage. Next, please. This is the site preparation on July 18, 2019. Next, please. Next, this is the site preparation on December 31, 2019. Next. Next, please. Okay. This is the site preparation on June 2020. This is the nuclear island area. Okay. This is the site preparation on February 26, 2021. This is the containment. This is the containment fabricated near the site. Next. This is the first concrete date on July 13, 2021. Okay, next, please. And in the last of my presentation, I will introduce the multiple application of ACP100. We all know the merit of nuclear energy with higher density, lower carbon emission, stable operation, no fracturing, and 1,000 megawatt large nuclear power plant can decompose 3 million tons of coal per year. Next, please. 18 in China, 18% end user of energy is for electricity, heating, and transportation. In year 2019, energy consumption of China, including the 24% electricity, 45% heating, industrial 24%, and the civil 21%. Transportation is 11%. Next, please. If we consider the ACP100, if we use ACP100 in the fields of electricity generation, as in Hainan Changjiang project, already under construction, the electric power of Hainan Changjiang project is 126.5 megawatt electricity. Refueling period is 24 months. Electric generation is 10 power of 9 kilowatt hour per year, satisfied for 500,000 families. Next, please. If we use ACP100 in the field of district heating and electricity generation, for example, in Gansu project, we have done the feasibility study in Gansu province, northwest of China. ACP100 can generate thermal generation is 6.55 million gigajoule per year, and also, in the meantime, it can provide 18 megawatt electrical. The electrical generation is 4.25 plus 8 power of 8 kilowatt hour per year. This is used ACP100 for district heating and electrical generation. Next, please. And if we use ACP100 for seawater desalination and electrical generation, we have done the feasibility study in Fujian Putian project near the seashore. ACP100 combined with low temperature multi-effect seawater desalination facility. The fresh water generation is 48 cubic meter per day, and plus 75 megawatt electricity in the meantime. This is ACP100 used for seawater desalination and electricity generation. Next, please. And last, if we place the ACP100 reactor on the floating nuclear power plant, we have done the feasibility study in Yantai project. We have done the feasibility study. If we put two ACP100 reactor on the floating platform near the seashore, it can generate 250 megawatt electricity for the land. This is the ACP100 used on floating nuclear power plant. Okay, that's the main use for ACP100. That's all my presentation, and thanks, and I'm glad to answer questions from the audience. Thanks again.
Thank you, Dr. Song. Well, questions are coming in. We'll take a quick look at the upcoming webinars that are planned. In September, a presentation on the development of in-service inspection rules for sodium-cooled fast reactors using system-based code concept. In October, sodium integral effect test loop for safety simulation and assessment, otherwise known as STELLA. And in November, a visualization tool for comparing energy options. We have one more quick announcement to discuss, and I'll turn the floor over to Patricia so she can talk about the GIF Industry Forum.
Yeah, thank you very much, Bertha. We have announcements about this GIF Industry Forum where all the, I will say, the vendors and the developers and the people interested by Gen 4 reactor system will participate. It's on October 3 to 6, 2022 in Toronto, Canada. You have the registration link here. I also encourage you to look at the GIF website for more information, and do not hesitate to contact me if you have any questions. Thank you so much, Bertha.
Thank you. Dr. Song, I have elevated you, so hopefully you can see the questions as well. The first one on the list talks about the safety systems resemble those of the AP600. Valves are present on the passive circuits. With what type of signal are they opened?
The signal of the safety system starts such as flow rate lower, or temperature higher, or pressure of the reactor higher.
Thank you. The next question reads, based on which elements, guides, or documents are the codes and standards mentioned on slide 31 developed?
So, 31?
Yeah.
Sorry. Our code is based on our National Nuclear Safety Agency. Is a nuclear safety design, such as half 10102. This may be equal to IAS SSR 1-2. Safety design of nuclear reactor.
Thank you. The first one is multi-part. It looks like question 1 is, what is the batch number of the core and burnup of discharge fuels? And number 2, how long does the passive core cooling system work without water replenishment for the IWST?
The core, the fuel assembly burnup is the average burnup is more than 40 to 45,000. And please read again the second question.
How long does the passive core cooling system work without water replenishment for the IWST?
The recirculation of the IWST, it can maintain the safety condition for the reactor more than 72 hours.
Thank you. How reliable of passive systems are calculated, which is used in probabilistic assessment?
Pardon?
How is the reliability? Oh, I'm sorry, I misread that. How is the reliability of passive systems calculated, which is used in probabilistic assessments?
The PSA, the possibility safety analysis, the equipment or instrument reliability data is from the national or international books, maybe such as US EPRI booklet. It's the same as the large nuclear power plant, because most of the equipment, most of the instrument is used from PWR type equipment or instrumentation. So the data of reliability data almost the same.
Thank you.
Thanks.
Why did CNNC select a PWR design instead of a BWR design?
In China, all the water cooling reactor is PWR type. We have more experience on PWR type reactors.
Thank you. In the Gansu project, which is a dry area in general, how is the cooling water supplied?
We use the air cooling tower. If we select the inland area site.
Thank you. What is the temperature needed for desalination and district heating?
Temperature, the multiple effect seawater desalination facility need the temperature about 100 100 degree. It's not very high.
Thank you. How is the reliability of passive systems calculated? Oh, we already did that.
Yes.
In a waste management system integrated in ACP, I'm sorry, let me try again. Is a waste management system integrated in ACP100? If yes, how does it operate?
The waste generated by PWR type is almost the same, but because the core and the coolant is lower than large nuclear power plant, the waste treatment system is smaller. But the principle of waste management system are like that of large nuclear power plant.
Thank you. Thank you again, Dr. Song, for sharing your expertise with us to present this very informative and interesting presentation on the ACP100. I also want to thank the audience for asking such great questions and being engaged in the presentation. It's very interesting to see the different perspectives.
Thanks.
That's all the questions that have come in. Patricia, do you have anything?
No, just I wanted to thank again Dr. Song, who volunteered to give this webinar. As you said, Bertha, good interaction with the audience. So thank you, the audience, for your participation as well.
Thanks, Ms. Bertra and Patricia. Thanks for your.
Okay. Goodbye,
I think
everyone.
we'll conclude, we'll conclude today's presentation and look forward to September. Thank you, everyone.
Bye-bye.
Bye-bye. Thanks. Bye-bye.